Mike's already pretty well told you about the standard introduction to the Ntsb. We're a relatively small agency by government standards. In fact, we qualify as a small agency. We report directly to Congress. We have no regulations that we are in charge of. We don't do any policy. We can't make anybody do anything. We do our best to talk people into doing things, seduce people into doing things, connive people into doing things, anything we can to put in place what our primary product is, and that is an investigation and the safety recommendations developed from that recommendation, which hopefully will inhibit those kinds of accidents again. To the extent we can, we try to work ourselves out of a job. To the extent that reality shows there are a lot of people who are trying to figure out how to do another kind of accident, although we have a lot of people who can't seem to come up with new forms of accidents. At any rate, as I said, we're a small agency. We have about 420 staff, and at the moment, 4 board members. 5 is our normal quotient of board members. So our product really is safety recommendations. Now, what I'm going to talk about today is give you some background on what the data show. We like to think we're a very data-driven organization. We'll look at what the accident trends are. We have a most wanted list. This is one of the ways that we get advocacy to take some traction. Every year we identify 10 items that are in a priority of some sort. It may be that it's a very often recurring accident. It may be that it's an emerging accident. It may be that we've had several in a row and just need to bring some focus to it. There are 10 items. 5 of those items really have something to do with general aviation, and those are the 5 I'm going to talk about, with a lot of emphasis on loss of control and procedural compliance. Rich Stovall already kind of introduced the topic of distractions and loss of control. I'll get into that more in a moment. This is what the accident trend looks like at the moment. From 2000 to 2014, the number of general aviation accidents has decreased from about 1,800 down to a little more than 1,200. So for that, we probably think we can pat ourselves on the back. About 1 out of 5 accidents is a fatal accident. Last year we had about 420 fatalities. This too has gone down. This is the number of fatalities in general aviation starting in 2000. So we went from 600 down to 400. But anybody who's been doing any flying in the last 10 years realizes we don't do as much flying as we did 10 years ago. And so when you start calculating this on the basis of an accident rate, how many accidents per 100,000 flight hours, the story starts to look a little different. That's the fatal accident rate, a little more than 1 fatal accident per 100,000 flight hours. And this is for all general aviation, basically all Part 91 operation. We thought we had something going last year in 2013 with a nice decrease. And unfortunately, it came back up again in 2014. So it's really kind of still in the noise level in the data. 1 out of 6 accidents is a fatal accident. So but with 1 times about 6, you can see that we've gone from about 6.5 accidents per 100,000 flight hours to a little closer to 700. The change is not going in the right direction. Now, everybody's aware, of course, that there's a lot of different kinds of operations that are classified under general aviation. Corporate, business, instruction, personal flying, just to name the 4 most frequent. So if I peel these back, and let me look at all accidents and break it down. This is the number that you saw a moment ago. This is the average for Part 91. If I look at corporate is right down at the bottom. Basically, a corporate operation starts to look like an airline operation in terms of its safety record. And not surprisingly, when you realize that corporate operation is probably a twin turbine-powered aircraft, is flown generally by 2 crew members who get paid for flying. That's their job. Either company policy or insurance requirements or both likely cause them to go for recurrent training on an annual, if not more frequent basis. They may, in fact, have a dispatch kind of organization or a dispatch function which helps provide them with routing, weather, catering, and so forth. So it really is very much like an airline operation in terms of how the flights are conducted. If we look at those airplanes used for business, and by used for business, I mean flown by somebody whose job is not to be the company pilot, but it's incidental. It probably is owner flown, but may well have some employee of the company flying the airplane. That's what that looks like. It's quite a bit greater risk than the corporate flying. So about 2 accidents per million departures back in per 100,000 departures back in 2000 to slightly more than 2.5 last in the end of 2013. Instruction, it's a little bit below average. It's in there around 6. So if these are all below average, and this isn't Lake Wobegon where all of the kids are above average, that's what personal flying looks like. Personal flying being the kind of flying that probably most of us do. Almost half the general aviation flight hours are classified as personal flying. So that's gone from 10 to 11, about a 10% increase over 13 years. If I look at the same data for fatal accidents, it's going to be about 1/6 of the rate for all accidents. Here's that average again. A little more than 1 accident per 100,000 flight hours, 1 fatal accident. And by the way, a fatal accident on the average has almost 2 fatalities. Some years there are no fatal accidents for corporate aircraft. For business aircraft, about 0.7, in other words, 7 fatalities per million departures, per million flight hours. Instructional flying is right in there with the business flying, and probably the reason being is that most instructional flights have somebody with a commercial license in the right seat. If they have a CFI, most CFIs are operating with a commercial license. So that accident rate is probably about where one would expect it to be. But again, for personal flying, we're over 2 fatal accidents per 100,000 flight hours, gone from a little less than 2 to 2. So this is the overall kind of picture for general aviation safety. If by comparison, I was looking at Part 121 airline operation in the United States, you have to realize we, in the past 5 years, have had 2 fatalities in all of that operation by a U.S. carrier or a U.S. In a U.S. carrier operating in the U.S. It was interesting to look at the data, and actually I put this chart together last night. I keep fully with the data. And I looked at the defining events. And for business flying, here's the top 5 in order. Loss of control. We've heard a lot about that today. CFIT, controlled flight into terrain, meaning flying a perfectly good airplane into the ground or into the water under control. Fuel, some sort of fuel issue. Often it's an empty fuel tank. Many times, however, it's an empty tank that selector is turned to with fuel somewhere else on the airplane. Component failure and power plant failure. If I compare that with instructional flying, loss of control is still at the top. But since a lot of instructional flying occurs near airports or near waypoints like VORs, where there's probably other traffic, likely, midair turns out to be number 2. Power plant failure is number 3. Controlled flight into terrain is number 4. Not surprising in a sense that a lot of the training flying is not cross-country oriented. And then the ubiquitous other category. So by comparison to personal flying, again, loss of control is right up there at the top. And I'll show you some data in a bit which shows how prevalent loss of control is. What part of the accident, fatal accidents, are related to loss of control. Power plant failure, CFIT, other and component failure. One interesting note in terms of CFIT, if we watch CFIT accidents over the last decade, they're showing a nice downward trend, and probably in large part due to the prevalence of handheld devices that have basically TAWS kind of capabilities. Have some sort of nav database which will alert you to the fact that the ground's getting closer to you than what you may realize. So why is general aviation on the most wanted list? Well, we investigate about 1,500 GA accidents a year. As you saw, GA accident rates pretty flat, hasn't improved much over the last decade, whereas airline accident rate has decreased more than 80%. And there's some reasons for that. And in large part, reasons go back to the way government and industry and the labor unions are all working together in activities such as the Commercial Aviation Safety Team, and we are replicating that process in the general aviation area. I'll talk about that in a little bit as well. So the personal flying accident rate has increased 10% over the last 10 years. Fatal has decreased 10% over the last 10-year period, but business flying has gone up 35% in terms of its overall accident rate, and fatal has increased 20%. So general aviation needs attention. And that's why it's on our most wanted list. So what is our most wanted list? We do this every year. We re-vote and identify new issues every year. General aviation, in one form or another, has been on the most wanted list ever since we revamped it about 4 years ago. Here are the 10 items: distractions, substance impairment, public helicopter safety, positive train control, rail tank car safety, mass transportation, particularly mass transit, loss of control, medical fitness for duty, commercial trucking safety, strengthened procedural compliance. So let me go through these so you get kind of a sense of how broad the Ntsb charter is. This was the first accident that I went to as an Ntsb board member. This occurred in September of 2010. And right in here is a GMC pickup truck, driven by a 19-year-old teenager who was texting while he was driving. And the story is, there was a work zone, traffic came to a halt, this tractor running bobtail slowed to a stop. The pickup truck driver wasn't paying attention, ran right into the back end of that pickup tractor, and the airbag module basically said there was a delta V of about 60 miles an hour. Never hit the brakes, no brake lights showed on the data recording. But he was probably alive after the collision. So there's one form of distraction. Now these two school buses were coming up on the accident scene. Ahead of the school buses was a motor coach. The motor coach driver saw the accident happen. He pulled off to the side. He got out quickly and started waving traffic down. So the school bus drivers got focused on him on the side of the road waving to slow down. They pulled over into the left-hand lane to get around him, pulled back into the right-hand lane to get around him, and ran smack dab into the back of the pickup truck. Literally rolled it into a ball, and it became the bearing that sent the bus up over the top of the tractor. So another form of distraction, roadside distraction. At the moment, there's a lot of focus on texting, driving, using portable electronic devices, and that's all valid and that's all real. But in many cases, there are more sources of distraction. Often the source of distraction that's the most is the kids in the back seat, or the kids in the or the spouse in the right seat. Let me show you another distraction. This was an accident that happened right about that same time. This is in Philadelphia. This is one of those ride the ducks in Philadelphia. You know, it's a tourist attraction. This is a barge driven by tied on the hip of a tugboat. The captain of the tugboat is working on his personal computer. He's got some sort of medical emergency going on. He's not paying any attention. He's just motoring down the Delaware River. So you can imagine what these folks are thinking right about now. And here they are. All but two of them survived, but two tourists didn't survive. Again, a distraction issue. So distraction is ubiquitous. It isn't only general aviation that we have to worry about distraction, but it's distraction basically in all modes of transportation. So disconnecting from deadly distractions, emphasis in aviation, take on the forms of things like sterile cockpit. You know, in a 121 world, basically below 10,000 feet, you don't talk about anything related. The only thing you talk about are related to operating the airplane. Appropriate use of portable electronic devices. I said a moment ago that CFIT is probably diminishing because of the use of handhelds. And I don't know what I would do without my two iPads. Over the last 3 years, I've worked myself away from having a JEP chart binder, and I carry two iPads, and I've got all of the same information. But when you do, you have to realize that the iPads need to be used appropriately. And by the way, don't keep them on the seat, because the time that you really need them is when you approach the terminal area. They've sat in the sunshine, that you look over and you realize they're black and they now need to cool off before you can use them. They work great when they work. Just be aware that if you're using them, prepare for the overheat. So in aviation, manage the distractions. You can just imagine, as Rich showed this morning, a lot of our loss of control is pilot paying attention to something other than the airplane, other than the airspeed or the angle of attack indicator, and getting themselves into a stall spin situation. Second topic that's germane to general aviation is impairment, substance impairment in transportation. This came from a study that was actually motivated by some data that we looked at in the Joint Steering Committee. The Joint Steering Committee is a government industry activity working general aviation, looking at a data-driven approach, a cooperative approach to enhancing safety. Substance impairment is a factor in all modes. In the study, we had 22 years of fatal accident data, medical data, on about 2,300 pilots who were involved in fatal accidents. Just pilots, not if they couldn't figure out who was flying the airplane, they didn't use the data. Basically, when there's a fatal accident, tissue samples, blood samples, and so forth get sent to CAMI, which is a civil aeromedical agency, part of the FAA. They can identify I think it's about 1,600 different either impairing substances or metabolites of substances that have been metabolized. So we had 23 years or 22 years of data, and we looked at the potentially impairing drugs. Now, it's very difficult to conclusively say this accident was caused by substance impairment. Caused by. We can say that it may have been involved, but in that large sample of pilots, we found that 11% of the early part of this group had some sort of potentially impairing substance in their tissues. But if you compare that with the most recent period, that's gone up by more than twice. 2008 to 2012, almost a quarter of the pilots have had some sort of potentially impairing drug. Now, what kind of drug? That's a good question. We broke it into four different categories. The bottom one is illicit drugs. Next is controlled substances, so prescription drugs. This isn't really a drug, but it's a potentially impairing condition which there was some drug in the system which you would find if the patient had, or if the pilot had some particular medical condition. But then potentially impairing drugs, and most of these are over-the-counter drugs, and that's going from 10 to almost 25%. So what kind of drugs? Sedating antihistamines was the biggest category. And in fact, diphenhydramine was the most common drug, and a fair percentage of the pilots had that in their system. Now, where do you get diphenhydramine? It's really quite prevalent in a variety. Sleep aids, allergy medicines, NyQuil. You can see all of these use diphenhydramine. So what's the hazard here? If you have a drug that has a dose period of 6 hours, how long do you have to wait for that to be out of your system? Anybody have a number?
6.
How about 5 times the dosing interval is what is the common rule of thumb. So if you take diphenhydramine with a 6-hour dosing interval, that means you got to wait almost a day and a half before it's out of the system to the point where you are not going to likely be impaired by it. This one in particular is slow to metabolize, and actually most medical practitioners will tell you that it takes really about 40 hours for it to clear the system. I would just bet that a large number of you have diphenhydramine in your medicine cabinet, and it's an effective drug. Just don't try to drive, do anything like fly, or look at the small print. By the way, this is blown way up. You ever try to read the small print on a medicine bottle? Marked drowsiness may occur. Avoid alcoholic drinks. Alcohol, sedatives, and tranquilizers may increase drowsiness. Be careful when driving a motor vehicle or operating machinery. Excitability may occur, especially in children. So don't couple that with flying an airplane. A little more on this. Here are those same 4 categories: impairing drugs, controlled substances, illicit drugs, and impairing medical condition. And it's quite interesting to note that the more your occupation, your paycheck depends on flying, the better you are in terms of low drug impairment. Sport piloting being the worst, ATP being the best. Without getting into the third-class medical certificate debate, if you have a medical certificate process, whether it's first class, second, or third class, you have a lower tendency to use drugs than if you don't have to have a medical. So the Joint Steering Committee took the tact that really says that we need to have much better understanding of the effects of medications. The FAA has a couple of publications, Medications in Flying and a Guide for Aviation Medical Examiners. The first is more layman's, the second is more medical. AOPA has a list published on their website. The General Aviation Joint Steering Committee, as I said, discovered this back in 2013, led to a letter to pilots that put out by the FAA and started this initiative, the initiative to get much better medical information out there. AOPA is developing a, AOPA is developing a training course. They either may have gone live with it or are about ready to go live. It's much more comprehensive than just medications, but it's a really good way to say, if we're going to have sport pilots, people flying without medicals, if to the extent we can, get them to take the time to learn about the effects, the correlations between medicines and flying. So that takes care of number 2. Number 3, this was an accident that came to the board about 6 months ago. That's basically a Chicago Transit Authority train trying to climb stairs. This occurred at O'Hare. It occurred at about 2 o'clock in the morning. Thank goodness it was at that time of day, because had this been a rush hour, this whole area would have been filled with people. Require medical fitness for duty. You know, you get your airman's physical, whether it's first, second, or third class, and that just tells you how you are medically at the time you took the exam. That says nothing about the situation or the current status of your well-being for flying at this moment or the time you go for your next flight. So it really says pilots are in the position of having to self-assess your fitness for flight. Are you, in fact, physiologically, medically, emotionally ready for this flight? The focus really of this particular most wanted list item, as I said, is on medical conditions. What would you think to be the most prevalent medical condition affecting transportation? Alcohol. It's not alcohol. Pardon? Say it again. Fatigue. Yeah, fatigue is another way of describing it. Actually, it's obstructive sleep apnea, which leads to fatigue. and it's undiagnosed sleep apnea, which is our biggest problem in the transportation industry in terms of medical conditions. We've got, in this particular case of the Chicago Transit Authority, this was a new operator, had been operating, as I recall, about 2 weeks. She commuted well over an hour each way. She wanted all of the overtime she could get, and that led her to working double shifts, and she literally fell asleep coming into the station and didn't wake up until the train shucked the wheels and started up basically the escalators. She didn't realize it. Okay, now we'll get into some related more to the subject at hand. This is an ATR 42 flying for Fedex by Empire Airlines. You know, this crew was really very fortunate. When you look at the flight data recorder, they were all over the sky on final approach, very extreme bank angles, pitch angles, and it just went through zero about the time they hit the ground. Now, what was the situation that led up to this? This happened about 4 o'clock in the morning, but actually fatigue really wasn't a part of it. The crews were well rested. But what happened was, the first officer was a bit junior. She was flying the approach. They were going into Lubbock, Texas. It was, as I say, night, some mild light icing conditions. And she put the flaps down and got flap asymmetry. One side came down, the other side didn't. Took them a little bit to figure out what the problem was. Rather than go to the procedures for flap asymmetry called for go around, go back up to some reasonable altitude, figure out whether you can get the flaps back off, recycle them, or whether you're going to have to land with no flaps. Instead, the captain decided to troubleshoot. He was almost out of his seat looking at circuit breakers, trying to figure out, gee, what happened here? Rather than fly the airplane, troubleshoot. The first officer wasn't doing all that good a job of tracking the ILS, and she asked the captain to take over. By this time, she got the airplane out of trim. He took over an out-of-trim airplane, very quickly went into stick shaker, and I think, as I recall, 5 instances of stick shaker came on before the airplane impacted the ground. They, by the way, walked away from this. But that brings up procedural compliance. Here's another procedural compliance issue. This is also a freight. This is UPS. This is the accident, the only accident in the last 5 years by a U.S. airline in the U.S. with fatalities. Pilot and co-pilot killed in this one. This happened in Birmingham, Alabama about 1.5 years ago. Again, this was early morning flight from Memphis to Birmingham. Not Memphis, Lexington, well, Kentucky. From the base on out. The situation was they were being held up a bit high until they got in close. They had to make a fairly rapid descent. They selected a constant angle of a descent approach. The ILS was, or the runway, their normal runway was out of service for an hour for some maintenance work. So they were cleared for a localizer approach to runway 18, and some hilly terrain preceded the threshold of the runway. A well-rested captain, a not so well-rested first officer. Although she'd had about 2 days off duty, she was burning the candle at both ends. So she arrived for the flight not very well rested at all. They didn't clear or didn't connect the approach to the flight plan. They, as I said, selected a constant descent approach, but didn't get it hooked up right. So the captain decided to make a vertical speed descent. They were coupled on the localizer. He didn't tell the co-pilot anything about what he was doing. He selected 1,500 feet per minute, and before you knew it, he flew right through MDA into the ground. Killed both of them. So again, a procedural compliance issue. Now, another procedural compliance issue was a board meeting that we held on Wednesday. Some of you may have read some of the trade accounts. Gulfstream 4 at Hanscom Field on the East Coast. Privately owned G4. The captain, the two pilots had flown with each other for something like 20 years. Flew almost with nobody else during that time. They developed their own way of operating the airplane. They managed to do it checklist free for the most part. Checklist free is not a good attribute, by the way. So they proceeded to taxi out with a gust lock on. Gust lock is supposed to be removed on the pre-start checklist. During the taxi-out checklist, you would do a controls-free check. They didn't do a controls-free check either, or they would have found it during taxi-out. They had another hint as they turned on the runway because the rudder pressure limiter light came on, indicating that, gee, there's something wrong with the rudder, which they talked about with just a short exchange, which ended in, They proceeded to take off. Now, Gulfstream had designed the throttle quadrant so that you could only bring the throttles up 6 degrees if you had the control lock in place, a mechanical interlock. Great idea, because it prohibits you from making a takeoff with the gust lock on. By the way, that was certified on the Gulfstream 2, Gulfstream 3, then by drawing review was certified on the Gulfstream 4. Nobody ever bothered to do a functional check of it, functional test, only to find out that you could get 24 degrees of throttle movement, and that was enough to get almost takeoff EPR. So they had basically the throttles against the mechanical stops and were able to basically get up to 152 before they didn't realize it until they called for a rotate. When they got to VR is when the pilot in command first uttered the words, steer lock is on, which he repeated 6 times before they went off the end of the runway at 92 knots. And by the way, they had 14 seconds to figure out after basically VR that the airplane wasn't going to fly. But in the meantime, they tried to pull the hydraulic shutoff valve to relieve the control surfaces of the hydraulic pressure so that they could pull the control lock off. And that took a number of seconds. Killed both of them, a flight attendant and 4 passengers. As I say, that one just came to the board. We had our board meeting, a formal board meeting on that on Wednesday. So procedural compliance is a real issue. And for that reason, it's on the most wanted list. So let's talk about the last one. This is the accident in Buffalo in 2009, where a Q400 basically was flown by 2 pilots, both pilots a little on the fatigue side. They were flying in light icing conditions, not to the point where it affected the flight at all. they got slow. They had the ice, they had a switch set for ice position, which raised the airspeed parameters where the stick shaker and stick pusher would come on. They got a bit on the slow side. The stick shaker came on, stick pusher came on. The pilot's reaction to it was to fight it, and it pulled back. And basically, you have a Q400 doing a snap roll. They killed one person on the ground, 49 people on the airplane. Loss of control. That's a Beach Bonanza, A36. Carlsbad, California. A guy with a fresh instrument rating took off from Arizona, headed for Carlsbad. Had never flown the airplane under IFR before. Got his instrument rating in another airplane. By the way, the weather was forecast to be below minimums at his time of arrival, but that didn't stop him from departing. You watch the radar track, and you see this guy is really lost, and then it goes into this. And you know how that one comes out. Something like 60 knots as the airplane hits the ground. So there are a lot of different ways to lose control. I've been pushing loss of control for now 4 years plus for general aviation, because 40% of our fatal accidents are loss of control accidents. It's the most deadly of the flight phases. Approach to landing, maneuvering, and climb are the most deadly flight phases. So here's business flying for about a 6-year period. Fatal accidents, and again, business flying means the airplane's being flown by somebody who is not a professional pilot, or what I mean by that is he or she's not paid for flying, it's part of their job, or they own the airplane. So there were 18 accidents during that time. Controlled flight into terrain is number 2, fuel related. In fact, system and component failure, this is the 5 that you saw before. Actually, there's not much below these top 5. If I look at instructional flying, there's about 60 loss of control accidents during that same 6-year period. 10 mid-airs, then some power plant failures, CFIT accidents, and so forth. And as Rich pointed out, if you take the bottom and add them all up, they don't come close to what loss of control is. So if there were 18 for business flying and 60 for instructional flying, what do you think loss of control is going to look like for that same period for personal flying? How about 600? That's a 6-year period, 600 loss of control accidents in personal flying. And again, personal flying is almost half of Part 91 flying. Power plant failure is number 2, CFIT, other system component failure, non-engine, non-power plant related. So this is a big number. Again, it's 40% of the accidents, fatal accidents. So because of the magic of PowerPoint, you don't see the relative relationships between this. So I took loss of control, put all of them on the same chart. And hence, personal flying loss of control is a focal point for the NTSB. Lest you think this is just a problem with personal flying, however, this is a chart that's put together annually by the Boeing company. And although the measure is a little different, this is numbers of fatalities, hundreds of fatalities. Loss of control is number 1, with what, about almost 2,000 fatalities over that period, 10-year period. So personal flying is loss of control, instructional flying is loss of control, business flying is loss of control. You see a pattern developing here? So where did these happen? This is kind of an interesting slide. We often think that all of them happen on final, or the turn from base to final. But what's interesting here is the initial climb is the biggest category. I'm sure this includes a great number of turn back to the airport on engine failure, probably quite a number of engine failure and not pushing over, so you set yourself up for a stall spin. Very little happens on crosswind. Not a lot happens on downwind. Base, a little more. Final, the VFR, IFR approach. Missed approach and go around. I think that's interesting too. A lot of people could, when faced with a go around, do a terribly poor job of handling the airplane. And Rich kind of alluded to it this morning. Somebody's trimming the airplane all the way through touchdown, and they get on short final and they've trimmed all of the weight off the wheel. And then they have to make a go around. They throttle up, and what are they trimmed for? They're trimmed for 60 knots at full power. Boy, that makes you have a fast look at the moon. So loss of control was addressed by the General Aviation Joint Steering Committee. As I said before, this is government on the form of the FAA, Ntsb, NASA, National Weather Service at times. The industry, being GAMA for the manufacturers. AOPA is a co-chair for this activity. EAA is there, NBAA. So it's a very good cross-section of the industry. We're using the same processes that CAST uses with slight modifications for the particular characteristics of general aviation. We worked on two areas that we've completed reports. We've worked on a third area that is just being completed. But the first two areas dealt with loss of control, first in takeoff, or rather approach and landing, and the second was takeoff and departure. So the process is you go into the data, you find where the maximum hurt is, you then study those accidents, postulate all of the ways that you could affect the outcome, and then sort through those to find which ones actually work and which ones actually can be done. What you don't want to spend your time on is the solution that really doesn't do much and is really hard to do. What you want to do is find the ones that are easy to do and makes a big difference. But a lot of those are done already. That's the low-hanging fruit. So the steering committee had a working group that looked at this, came up with 28 different safety enhancements. So they included angle of attack for new, current, and retrofit, aeronautical decision-making, stabilized approach, single pilot crew resource management, medication effects. This is where the medication study was initiated, weather technologies, and so forth. So 28 of these in all. When we did the second work group on the departure, takeoff and departure, we also added another about 6 different safety enhancements. But the most prevalent one was angle of attack. It had the biggest bang for the buck. Of course, the problem is trying to get this on airplanes. And the other problem we had going into it was, so you go to the FAA and say, I want to put angle of attack information on the airplane. And they say, okay, that's a major mod. And it needs to be certified. And by the way, that's going to be, the market says that's about $10,000 to $12,000, if not more. That's hard to get something like that on as a piece of safety gear. Particularly when some friend at the hangar owns an RV-6 or RV-10 rather, And an experimental amateur built airplane, they put it on for about $800 or $1,000 in parts and a couple hours of labor, and don't have to have anybody sign it off. No field approvals. So we had a lot of discussion around the subject of, if you put angle of attack information, it's a representative of a safety system, which the airplane was safe before, it's going to be safer with it. Why should it be a problem to certify? Why should it be so difficult to get on the airplane? Which led the FAA, particularly the Small Airplane Directorate in Kansas City, to take a very close look. And in fact, we had a really great ally there, Earl Lawrence, who was the director of the Small Airplane Directorate. And his background included several years as a vice president of EAA, Experimental Aircraft Association. And the policy eventually was changed so that a piece of safety gear can be put on the airplane if it's been manufactured to some standards, particularly in this case ASTM standards. It's not a TSO device anymore by the FAA. It's installed as a minor mod and on a non-interference basis. So it's not, as Rich pointed out, it's not to be used as the primary approach information. It's supplemental, but it's much better than speed in terms of its relevance for the right approach speed. So without spending too much time in Aerodynamics 101, actually it was Aerodynamics 301 at the University of Michigan. But the airplane's going to stall at a critical angle of attack no matter what the weight is, no matter what the density altitude is, no matter any other parameter. That's this part right up here. So as you increase angle of attack and the lift goes up, it gets to a point where it doesn't go up any longer. All this way on this side, when you push forward, the houses get bigger, and you pull back, the houses get smaller. But you get over this side, and you pull back, and the houses get bigger again because you have stalled the airplane. So that's great information because, as I said, stall occurs at a specific angle of attack no matter what the weight of the airplane is, no matter what the airspeed is, it's always going to stall at that same angle of attack. Surrogate airspeed is a surrogate for it, but that means you're basically in a 1G situation, coordinated flight, and at the reference weight. It works all right for a 150, where there isn't much weight change. Well, there is kind of quite a bit of weight change when you've got two heavy students, a heavy student and a heavy instructor versus a light pair, but nevertheless, it gets more critical as airplanes become more utilitarian and you can vary the load on the airplane. So that's led to either angle of attack devices or angle of reserve lift device. This is in particular a Honeywell device. But as I said, the FAA installation policy has been changed so that it can, if built to ASTM standard, can be installed as a minor mod signed off by a mechanic. This is just the first of more safety equipment to come to be able to be installed as a minor mod in the airplane. So I would be remiss if I didn't point out, as Rich has already pointed out, for stall recovery. When I went through basic training, the emphasis was on doing a stall series. The emphasis was on doing stalls, not recovering from stalls, doing stalls. If we talked about recovering from stalls, yeah, power up as much as you can, fly the airplane on the verge of stall, lose as little altitude as you can. By the way, you're sitting right on the edge of a stall spin accident while you're doing that. A lot of work has been done in the transport industry, which led to the upset recovery training aid, which the industry put together. The upset recovery training aid basically says unload the wing immediately, reduce the angle of attack below stall. If you've got stick shaker, get it out of stick shaker. If you've got stall warning going off, reduce it, unload the wing till the stall warning goes off. Level the wings, then adjust thrust, so that you don't overspeed, and back to level flight. Again, don't try to power out of a stall. So on your desk, on your table, are some of these safety alerts. About 4 years ago, we decided to use these to try to get messages out the best we can to the widest number of people. So the safety alert format was used. It's a very compact way of describing an issue, giving some examples of accidents resulting from that, what you can do to avoid the accidents, resources, hopefully enough information to act on to prevent some accidents. Those have come in a number of different flavors. This is an incomplete list now, but we focus on stalls, IFR into, or VFR into IFR. We had a conversation at lunch about airplanes talking to you. If you fly the same airplane a lot, you know when things aren't quite right. You know, it's one of those, gee, I wonder what's wrong with it today. So, just to quote a famous bridge player, learn all you can from the mistakes of others. You won't have time to make them all yourself. I paraphrase that for this application. Learn all you can from the mistakes of others. You won't live long enough to make them all yourself. So, Josh is going to talk about airplane accidents. I'm going to say there's a lot of information online available from your armchair, so to speak. A lot of dockets now. You know, somebody told me one day they were kind of disappointed because all they ever see is that one page of accident report. And that's what a lot of people think. We only put out one page. But in fact, there's generally a much more in-depth report on a lot of the accidents. There are radar tracks, weather information, interviews with pilots, family, etc. All available. A lot of photographs. I mean, if you're trying to put together some teaching material, there's a treasure trove of photographs which you can be used to show, don't do this. All available on the website, ntsb.gov. So to finish, a quote by Douglas Adams, who's the author of Hitchhiker's Guide to the Galaxy. Human beings who are almost unique in having the ability to learn from the experience of others are also remarkable for their apparent disinclination to do so. So thank you much.